Hey there, Mr. Wilford here again, and I just want to talk a little bit about Chapter 5, Section 3. Again, this is kind of similar to the last section. There's a few terms that we need to go over, a couple of theorems and things like that, medians and altitudes of triangles. Um, and so first of all, let's talk about what a median of a triangle is. Basically, a median of a triangle is when you take a segment from the vertex of a triangle and you go until you hit the midpoint of the opposite side. So in other words, this distance from A to D is the same as D to B. This right here is the median. Now, of course, we have three angles, three sides of a triangle, and so we end up really with three medians of a triangle, and that's what we want to look at next. There's a construction that you can kind of read through here. Basically, we're finding the midpoint of each side, and then what we're drawing is from a segment from the vertex to those midpoints, and what we're looking at is this point where all three of those lines meet. We're going to label that point P. This point P, remember we talked about a point of concurrency, and that's where we have three lines meeting. In this case, we're talking about the medians of the triangle meeting, and this is called actually the centroid of the triangle. And the centroid will always be inside the triangle. It is also called the center of gravity. Really, this is where if you were to try to balance this triangle, this point P right here is where you'd want to put your finger to balance that triangle. It's kind of the center of gravity. It would balance the triangle perfectly. Now there's a theorem here that goes along with the centroid, and basically it has to do with the distance of part of your median compared to the whole thing. So um, if we just take a look at this first one here, it's actually 2/3 of the distance. So this distance from A to P, the centroid, that distance is equal to 2/3 of the whole median. And so from that distance from A to Y. So AP is equal to 2/3 of this distance AY. And that's the same with all of those uh, lengths there. Okay, there are a couple of examples that you should just take a peek at, read through, that have to do with some of those theorems there and medians of triangles. Also, we have something called an altitude, and the altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. So this is a little bit weird to look at here with the different colors, but you want to look at this black triangle right here. This is triangle QRS, and if we take a perpendicular line here to this side, if we take a perpendicular line and go through that vertex, that would be the altitude. The altitude we oftentimes think of as the height of the triangle. Well, depending upon how your triangle is drawn, this right here would be one altitude of that triangle. Um, if you take a look at point R here, now notice that the perpendicular, there wouldn't be a perpendicular line that you could draw to this side. So you have to extend that side out, and then you draw your perpendicular line there. Same thing with this point S to this side here. Where all three of those meet again, this is called the orthocenter of the triangle. Again, this is a point of concurrency where all three lines intersect. So this is the orthocenter of a triangle, is where the altitudes of a triangle all meet together. And again, a couple of examples for you to look at there as well. Once again, as always, if you have any questions, please let me know. Thanks.